me to start a recording. Right. And so 15 work lab work and 10 marks will be for either tutorial, mini project, presentation, or journal, which also includes your experimentation. So oral exam plus term work, that comes out to total 50. So total is 100 plus 50. This is 150. Required courses for this for doing this course is engineering mechanics and kinematics of machinery. Both these subjects are you have already studied. We have some predefined outcomes and objectives. You can go through the syllabus, and we are going to do all these things, various activities during the entire semester. Okay. So let's go briefly module wise. You have 5 modules. First module will cover basic vibration, followed by free vibration of single degree of freedom. And then you will be solving problems with viscous damping and also with Coulomb damping. So both the types of damping will be you will be doing. So earlier, before this, you had a subject called dynamics of machinery. So in that there was a lot of stuff was omitted, and mechanical vibration is a very good subject from from your what you say for from your personal growth point of view as a career option. It is one of the favorite subjects for people who are doing MS. Every person who is doing MS in most of the university will be doing some flavor of these subjects. Either it will be exactly mechanical vibration, or it will be vibroacoustics, which deals with sound and those kinds of effects. So this is a very popular area of research and study. So a lot of work has been is goes on in this work, especially internationally, if you are looking from that point of view. So it is very important to study all these subjects in this subject in detail. So that is why we have reincorporated some of the things which were omitted, and some of the things which are omitted were 2 degree of freedom system and multi-degree of freedom system. So these systems were omitted in dynamic machinery, or they were just marginalized, and the volume was too much to do justice to the entire content. Then we'll be studying harmonically excited vibration, that is force vibration with single degree of freedom system, and followed by vibration measurements and application. So you will be studying various types of vibration measuring, basically primarily 3 types of vibration measuring instruments, and how they can be designed to adapt to certain suitable condition. Okay. And then you will also be studying machine condition monitoring and diagnosis. So here you will be studying how to analyze the vibrations. Okay, this is a very good area. uh, uh, Advanced version of this content, you have a independent subject called as tribology, which deals with these kinds of subject. uh, that is one of the aspects of tribology. And of course, measuring the vibration is a very important aspect of studying the vibration. If you have to study the vibration, the first thing you need to do is measure the vibration. Okay, and there are some various instruments, and one of the most advanced instrument is the FFT analyzer. So you can analyze the vibration, with all, and study its characteristics. Of course, we will be doing all these things both in the practical and theory sessions. And also here we have included the effects of vibration on environment and society. Okay. So I don't know, if you have observed such things, that the effect of vibration on human being. One common example, I would like to give is, suppose you have a house chimney, and that is used for uh, exhaust purposes, and you keep it on, and it has a lot of vibrations. And after that, sometimes you forget to switch it off, and you realize that something is disturbing you. And suddenly you realize that the exhaust chimney is still on, and when you still switch it off, you feel that, oh, this was what was annoying me to such a great extent. So the ergonomics aspects of design and its effect and the effects of vibration on human beings, that also will be discussing. That will be done in form of a paper review. So either one lab session or one, mostly we will be doing it in the lab work. Okay. Then you will be starting rotor dynamics. So rotor dynamics is basically the effect of a rotor. So what is a rotor? If you have anything that is mounted on a shaft, such as a pulley or a gear, then that you can refer to it as a rotor. Okay. So what we'll be doing is we'll be studying a single rotor system as well as a multi-rotor system, the critical speed, and we'll be studying how to due to sometimes what happens when these multiple rotors are mounted on a single shaft, there is some kind of manufacturing defect which causes some eccentric loading. Okay, so the shaft in that case experiences unbalanced forces and that induces vibration. So how to eliminate that, we'll be studying some basics on that. And also we'll be studying vibration isolation. So vibration isolation is something is vibrating and you don't want that vibrating to be affecting the surrounding. So what you do is you isolate that vibrating instrument, a vibrating object, so that it doesn't cause damage to its surrounding. For example, you have a what you say a shaper machine. So shaper machine when it is doing its operation, it will induce a lot of vibration, and these vibrations are transmitted to the floor. Okay, so that might damage the floor. So you might find that before setting up any kind of such heavy duty machine, there is some groundwork which is done at the base in form of cement and concrete, just to prevent the vibration directly being transmitted to the floor. And because the floor will be weak, it will have some tiles and also it will damage that, and it will also dislodge the machine from its position. So that is not desirable. It might cause accident. Okay. Okay. Now next part is the lab work. So lab work, 8 experiments are to be done. I have listed here 15 experiments, and we can do experiment which is related to our subject, and it can go outside of this list also. So it is pretty flexible. The entire course content is pretty flexible. One more thing I forgot to mention is that, see, some of the problems maybe during the theory session or during the lecture session I will be trying to solve it using Python. Okay. So one thing which I have realized over a period of time is that mechanical engineering students develop a sort of a phobia towards programming. Okay. So what I have tried to do is that incorporate some sort of programming, either Python programming or MATLAB programming, something which is easily installable on your home computers. So we will be solving some of the problems using a program. Okay. So I don't know how much in detail I can go with that aspect, but that thing is not like may not be a part of your examination in any form, but it will be a important addition, or it will give you an important additional dimension to your understanding of the subject and application point of view. Because in practice, when you go outside, you won't be doing any calculation using pen and paper. It will be all based on program. Okay, so that is one aspect that has been done. uh, and as far as the lab work is concerned, the lab work will also have in addition to your traditional experiments, uh, which you're doing using the setup in your lab. So in addition to that, we will be also doing some simulation based experiment. Okay, so that will be either in MATLAB Simulink, and I'm trying to migrate from MATLAB to some open source software, so that you can easily install it on your PC. Right. And so I think that will be interesting. The lab works. Plus, we will be studying vibration using various simulation tools. There are some virtual labs that have been created by the Ministry of Human Resource Development of India, and these labs, virtual labs, have been created by various IITs. and they have created a sort of program which runs, and it is very helpful. And so that will be studying. So all these things, and especially because this is the Corona semester, I thought that there are two ways to do the experiment. Either you can record the experiments and ask the students to go through that video and do the experiment. So we will be doing that, but I think doing all the experiments in that format is very monotonous, and you don't get to learn too much. So this simulation aspects of experimentation has been included. We will be doing exercises on Simulink, MATLAB Simulink, or alternative open source software where we will be studying basic vibration system. And then you can, once you know how to do it, you can enhance your knowledge on your own by doing research on your own, and then that will be helpful to you. All these no software, they are very important from from industry point of view. If you are doing research work, you should know some of these softwares like Python. Especially today, in today's time, Python is a very much in demand. Reason for see, you have either Python or you have MATLAB. So reason people are preferring Python because it is an open source software, it is a free software. And there are some softwares like which I have introduced in a value added program that I ran called as FreeCAD. So it has a commercial license. So in that also you can study vibrations. So I don't know, anyone of you attended that WAP course from this batch? Hello.
No, sir.
No one? Okay. So in that we did a simulation of a modal analysis of a rotor of an impeller. So we did the modeling using this open source software called as FreeCAD, and then we did a modal analysis. So we'll see what is modal analysis. No, in just a basic introduction we'll see in today's lecture. So maybe I don't know. It depends upon the how much response I get from the students. So that you can actually see the various modes of vibration. It was a very interesting exercise that we did, and it is very much in line with the industry. So similar exercises. So these are very advanced exercises of modeling and simulation that we did during the validated program. So that program maybe during the end at the end of the semester I will be running it again. So maybe during that time you can join that course if you are interested. Okay. Uh, for the course, we will be using only one textbook, that is SS Rao by Mechanical Vibration by SS Rao. So as far as textbook is concerned, we will be following only that one book, plus whatever notes I will be giving during the lecture. So I will be giving you exhaustive notes. Um, and I have already sent today's notes. Uh, has everybody received the notes? PDF file I have sent?
Yes, sir.
Yes. Yes. So the way I would like to, I want to run this lecture session is that I will be giving you notes for the lecture one day in advance. So if tomorrow is a lecture, as far as I will try to do that. So that you'll have that lecture notes in advance. So what it does is that you can, if possible, you can take a printout of those notes, and you can follow it during the lecture because during in the lecture I will be adding so much more content to those notes. So you can write those things on the slides itself. Okay, so that is the one way to attend the lecture. All the When I was to attend a lecture at Michigan Tech, that is the method which we used to follow. Before the lecture, we used to get the notes, and so we used to take the printout and go to the lecture, and whatever additional notes the teacher used to give, we used to write it on that presentation slides. So that is how we used to maintain the notes. It is a very good practice to maintain your own notes. I will be giving you the notes, but just taking those notes and not working on that might help you to get through the exam, but will not help you to understand the subjects thoroughly. Okay. A term test will be of 25 marks, and minimum 2 modules will be has to be included in the test, and it will be 1 hour test. And how it will be incorporated into final grading, that I have already explained earlier. Um, so yeah, this is just about syllabus. We are some of the additional things which have never been addressed while learning any of the subject. Not only for this subject, you'll find that I have included programming things. I have also included things such as ergonomic design. I have included things such as green technology in this lecture. So all the sustainable aspects of design are also included in this lecture. All right, so let's see. I hope you enjoy the course. So let's go through some of the basic things. So that is just about what the syllabus is. So let's get back to our presentation. All right. So this is our first introductory chapter. So after we complete this chapter, so uh, you should be able to learn in briefly the history of vibration, how the subject, how, why, and how the how people started studying this subject. So you will learn that and learn some fundamental terms in vibration analysis and their definitions, and indicate the you will be able to indicate the importance of study of vibration. You will be able to classify this vibration, and you will be also able to learn the steps involved in vibration analysis. And at the end of this first chapter or first module, you will be also able to compute some constants such as spring constants, masses, and the basic elements of any vibrating system. So if you consider any vibrating system, there are some basic elements, and the basic elements of this vibration system are for an undamped system are this spring and a mass, and you have a damper. All right. So something to store the kinetic energy, something to store the potential energy, and the something to control the vibration. Okay. So these are the various basic. These are some of the basic elements of a typical vibrating system. All right. So let's start with why what was the origin of the subject and why people started studying this subject. So the people started studying this subject because they were interested in vibration when they first created this musical instrument. Okay. Since and if you I don't know if you are aware, there is a famous company called as Bose, which develops this very high quality audio systems, speakers, and so that is one of many the musicians and philosophers, as no, they are the ones who are attracted to this area because of the, and they try to establish some laws of sound production, and try to improve the quality of the music that was to be generated by the this various musical instrument. As you can see, the harp, there is an instrument called as harp, and the various versions of harp have been developed, over a period of years, starting from 1500 BC to 3000 BC. Okay, and uh, so the many versions you can find it in museums also, where uh, and they are also depicted on ancient architecture such as Egyptian tombs, etc. Okay, so the first person to study this thing mathematically was Pythagoras. Okay, so Pythagoras he conducted experiments on this vibrating string. Okay, a vibrating string is this is like a simplistic instrument which he created. So there are some knife edges, and to the end of to maintain tension in the string, he suspended a weight at the other end. So some weight was attached to this string, and it is passing over the pulley. Okay, and he used to plug these wires, and he found that when you change the distance between these knife heads, the notes coming out of this instrument used to change. Okay, so so he developed the concept of pitch, and but you have this thing called as a commonly used term in vibration is called as frequency. So that was developed much later by Galileo actually. Okay, so Galileo was also a scientist who has contribution in various area. So he developed the concept of frequency. Right. There were, you can also find references in various texts where the vibration analysis was also done in Asia. Okay, there are and as I said that a lot of because as far as music is concerned, there is a lot of history in Asian countries also. Okay, so this is the instrument which was developed by a Chinese astronomer called as Zhang Heng, and what it is this is the first seismograph. Okay. It is a seismograph. Do you know what is a seismograph? What is the aim of the seismograph? Anybody? Basically, seismograph is an instrument which is used to measure vibrations. And yes, you have never heard this term, yes? Yes.
Quick.
Earthquakes, correct. So these instruments are used to predict the earthquakes. Okay, so whatever you are seeing on the screen, this was the first seismograph which was developed. Okay, so I will just demonstrate. So what I will just describe it briefly before I run the video. So what it is that this is a jar. Okay, and at the on this jar on the outside there are this 8 dragons. Okay, so 8 dragons are in along the 8 directions. So 4 direction are north, south, east, west, and in between are this like northeast, southwest, like that. Okay, and each of these dragon has a metal ball, and which is placed in the mouth of this dragon. Okay, and inside this there is a lever mechanism. So what that lever does is when it tilts in a particular direction, it releases that ball and it falls down on this. There are these toads at the base of it with that mouth open, and this ball will fall in the mouth of those toads and it will make a clanging noise. And depending upon where the metal ball has fallen, you can predict the direction in which the earthquake is occurring. So let me just demonstrate this using this video. Right. So as you can see, there are like 8 dragons and each of them has a metal ball in their mouth, and there are these 8 toads that are played. So whenever there is vibration in particular direction, the ball drops. You can see inside there is a lever mechanism. It is like a inverted pendulum. All right, so this is how the first seismograph was invented. Of course, when you talk about anything regarding mechanics, the first name which comes is Newton's law, and Newton's second law of vibration has been used in deriving the motion. So we will be using this Newton's second law in deriving the equations of motion. All right. And so also because there was so much keen interest in music, there was and try to improve this instrument. So there was to be a lot of research that was done on musical instrument, and basically this musical instrument is basically research on a vibrating string. Okay, so this first mathematical model of my vibrating string was created by Brooke Taylor. in 1680 in 1730. Okay, so this was an English mathematician. He created this equation that is the using differential calculus in 1713 on the motion of a vibrating string. All right. So when you study advanced vibration, there you where you have infinite degrees of freedom, you have this no that course includes this derivation for this natural frequency of this vibrating system. Okay, so and whatever equations that were derived by Taylor, so you will find these names very common in our entire mechanical engineering. Okay, Taylor, Galileo, and what do you say? There's so many typical names who have worked in diverse fields of mechanical engineering, starting from like fluid mechanics to design and all sorts of areas. Okay, and so whatever these equations that were developed by Taylor, later on Galileo conducted some experiments. All right, and the experiments conducted by Galileo were in very much agreement with the whatever equations that were developed by Taylor. Okay, and later on, uh, so when you have a system which is multi-degree of freedom, there is it has multiple natural frequencies. So all this prediction was done by Bernoulli. So all these things I'm going to discuss brief, in the next few slides. What do you mean by degree of freedom? All these things. Okay. I hope you are paying attention to this, because at the end of the lecture you will be doing a quiz based on the discussion we are having currently. Okay. Now, one of the things when I talked to you was mode shapes. Okay, so mode shape means you if you have a material which is vibrating or it is subjected to vibration, it will cause the vibrating body to move in a specific manner. Okay, so that is nothing but the mode shape. Okay, and there is an interesting experiment which the like who are developing musical experiments. So I found this video. This is called as Chladni's plate. Okay, this is called as a Chladni's plate, and so you can this experiment, this video will demonstrate what we mean by mode shapes. Okay. So what this video is, this is a vibrating plate, and on this vibrating plate there are some sand particles. Okay, and as you change the intensity of vibration, you can see that the shape of the particle. So whatever shape you see of this particle, that is basically the mode shape at that frequency. Okay, when you change the frequency, this shape will also change. All right. So this is a very practical way of explaining what you understand by mode shapes. Okay, so whatever shapes you are seeing of this sand particle is the shape of the vibrating object, and that is nothing but the mode shape. Mode shape. Okay. So let's just quickly revise. What terms we have learned so far. Okay. So first term which we have learned is the natural frequency. Okay. So natural frequency is defined as is the frequency at which the system tends to oscillate in absence of any external force. Okay. So that is the first definition. All right. So please keep this in mind, because in a Viva exam, when I at the end of the semester, when I do this Viva, nobody is even able to answer such a basic question as what is natural frequency. All right. So I am telling you today the first question that I will be asking you during your oral exam for 50% of the student is what is natural frequency. And even if I tell you today, 50% of those students will not be able to, more than 50% of students will not answer will not be able to answer the question. All right. So What do you understand by natural frequency? It is the frequency at which the system tends to oscillate in the absence of external application of force. So that is called as natural frequency. All right. Next term which we have learned is resonance. Okay. So what? If you listen to that Chladni's plate experiment, if you've seen that at a particular frequency, the shape of the sand particles becomes very sharp. Okay, so in that case, what is happening is that there is a forcing frequency because of the external disturbance. The force is applied or the vibration is applied to the system, and there is a natural frequency of the system. Okay, and when the external forcing frequency becomes equal to the natural frequency of the system, you get a phenomenon called as the resonance. All right. So when you get this resonance, you get these sharp shapes, and these shapes are basically called as the mode shapes. All right. So mode shapes are nothing but the shapes of vibrating element associated with the frequency of vibration, associated with the frequency of vibration. Okay. So what are the terms which I have learned? Natural frequency. We have learned about resonance. We have learned about mode shapes. Okay. So very important terms that you will be always using during this subject. Now whenever any lecture on introductory lecture on vibration is given, the lecture cannot be complete without this video of Tacoma bridge collapse. I don't know if you have seen this video earlier. So basically this is a bridge, okay, and this was built I think it was in US, and the bridge was subjected to wind vibration due to induced due to the flowing wind, and you can just see what happens to this bridge. So I'll just play the video. Right, so the wind is blowing and suddenly the bridge starts to vibrate and it collapses. Okay. So what happened here? Okay, so this is just a rough model of the bridge. Okay, so you can assume it to be a rectangular cross section, and this rectangular cross section, this cross section is was subjected to simultaneously two types of vibration, that is translational vibration plus rotational vibration. Okay, so the total vibration was some vector addition of these two types of vibration, and when you plot these vibrations, you get some kind of, you can get like some kind of sinusoidal wave. Okay, so this is the frequency with which the bridge is vibrating, that is the frequency of vibration, that is omega. And because of the conditions of the wind which was blowing, what happened is that the external forcing frequency became equal to the natural frequency of the system. So when that happens, when the forcing frequency becomes equal to natural frequency, we get what is called as, just now we described, it is called as the resonance. And when the system starts to vibrate at resonance, the amplitude of vibration is very high. Okay, you get the maximum amplitude of vibration when in such condition. And yes.
Sir, can we say that the frequency of the wind may correspond with the frequency of road? I mean, equal frequency दोनों हो जाएंगे, ऐसा बोल सकते हैं क्या?
That is what is happening. See, because the wind is blowing, right? That is the source of vibration, and that is causing the whole bridge to vibrate. All right, and the system has some natural frequency. Okay, and it's happened so that the natural frequency match the forcing, the frequency with which the wind was blowing and causing the vibration match the natural frequency. Okay, so amplitude and amplitude was at that case it was maximum. So basically, what do you mean by amplitude? See, the whole system is getting deformed. All right, and there is some permissible deformation that can be allowed as far as some of the material which is used in the bridge, such as concrete or the metal bars, or there might be some bolts attached to it, and the way in which the forces was induced in these various elements it exceeded the permissible safe value, basically. All right, that is what happened, and so some of the elements failed, and then that caused the entire bridge to fail. Right? Any other question you have? All right, you can ask any questions if you want. So basically what I'm trying to explain is what are the various applications. Okay, so this is the application in civil engineering, or no, not exclusively civil engineering. Mechanical engineers also work on structures, but generally structural engineering is an area of civil engineering. Okay, so this area is diverse application. Now another application is this now aircraft industry. Okay, so when the aircraft is flying, the wind again induces various vibration, and that will induce vibration, and that will cause the system to vibrate at various mode shape depending upon the frequency. So let's see. So this is a test setup for this um, X56. The name of this plane is X56. Model name is X56, and it is subjected to full body ground vibration test. So let's see what happens. So if you can see that all over this over the body of this plane, there are some wires which are attached. So basically these are the probes which are attached to the key points on the plane, and these probes are connected to a monitor, so the reading will be displayed on the monitor. So let's see how this is done. So a simulated flow of air is passed over the system, and as you can see on the computer, the various amplitudes of vibrations are recorded. Okay, so this is another application. It has application in aerospace industry. Um, it has applications in where you have to do finishing operations. So this is a deburring machine, and in this deburring machine there are various this hard what do you say polishing elements. So basically burrs are, if you are doing any machining, there are some small striations or small particles of metal which are like weakly attached to the what do you say the finished product. So this finished product is like put in this what do you say sort of a bath of this uh, what is it, the deburring elements. And if you see this entire vessel is attached to a system which has a spring and a damping element. Okay, so this entire system will be vibrating, and it will remove the burrs on this machine element. This these small pieces, these are the machine element. It can be anything, some kind of tool or something like that. Okay, right. So this is another application. So let's now go through some basic concepts of vibrations. Right. So what do you mean by vibration or oscillation? So any motion that repeats itself after an interval of time is called as vibration. Okay, so this is the first definition you should keep in mind. All right. So the position 2 is called as the mean equilibrium position. Alright, so initially the pendulum is at rest at position 2, then you give some external disturbance to this, and it goes to one extreme position 1 to another extreme position 3. Okay, so this 1 to 3, this arc which is defined, that becomes your that becomes your amplitude. So that will be in terms of angle, that is theta. Okay, so this is the example of a simple pendulum. Now, a typical vibrating system includes some basic elements. So it includes this element to store potential energy, So this element which stores the potential energy is called as the spring or any form of elastic material. It may not be always like a spring. It can be some kind of elastic material. Okay. Then it also needs a means to for storing kinetic energy. So that element is basically your mass or inertia. Okay. And it also needs by which the energy what is whichever is stored in the system should be gradually dissipated. Okay. So it cannot be dissipated suddenly, because sudden dissipation of energy is also required in some application. But somewhere along the line, for some parts, you need that energy to be dissipated in a gradual manner. Okay. So that energy is lost by in a gradual manner. So that is accomplished by this third element that is called as the damper. Okay. So these are the three basic elements of any vibrating system: a spring, mass, damper system. So a vibrating system is called as a spring, mass, damper system. All right. All right. Any questions? All right. Now we'll go for the classification. So classification based upon degree of freedom. So degree of freedom are number of independent variables which you are required to define the motion of the system. Okay. So you can say there are, so if there is a single mass attached to a spring, you need one variable x to describe the motion of the particle at any moment of time. If there are two masses m1 and m2, you will need two variables x1 and x2, and so on and so forth. And if you go on keep on increasing this number of element to infinity, then you get what is called as the, so this system of masses, this is called as a discrete system. Discrete means the system is separated by there are finite masses and they are separated by some finite distance, or and there is a spring which is attached to in between these masses. Okay, so this kind of system is called as discrete system or a lumped mass system. So whenever we are doing modeling, we are assuming that the system is a lump mass system. Okay, we are assuming that the entire mass is concentrated at some point and it is attached to some kind of a elastic element. Right? Now, if you go on increasing this number of masses, and if you make this then this go on discretizing the system, then this system as this number of masses you tend to infinity, this system will become a continuous or a distributed system. Example is a cantilever beam. Okay. So here in this example, you have seen you can say a cantilever beam, and each of this point will have individual definition. Now, depending upon what kind of analysis you want to do, you can convert this into a lump mass system by assuming that this is connected to elastic element and the entire mass of the stream of this beam is lumped at a single into a single mass m. All right. So this is what we generally do whenever we are doing modeling. Depending upon you will not be doing analysis of system with infinite degrees of freedom. Okay. So maximum degree of freedom for as far as will be 3, and in addition to that you will have some system which will have in which you will be doing system with multiple degrees of freedom, also more than 3, but there are special methods for analyzing systems. So we will go through that as and when the content comes. Any questions? I'm just discussing very basic stuff today. All right. So I think this is good enough for today. So now what I want to do, I have sent 3 quiz links. All right. Have you all received the links?
हेलो सर, लेकिन वो क्लोज दिखा रहा है.
हाँ, I will open the links now. Just hold on a minute. Stop sharing for the moment because you will be able to open this links. Just a minute. All right. Okay, so you can go to the quiz link first. You can just refresh the page. and you should be able to answer these quiz questions.
हेलो सर.
Yes.
सर अभी मतलब एपीएम का लेक्चर था ना सर, तो अभी लेक्चर मतलब पोस्टपोन हो
हाँ,
रहा है क्या?
वो लेक्चर है ना, वो my lecture was at 11:20, so that lecture will be at 11:20.
ओके सर, थैंक यू.
Okay, so I opened up all the 3 links, so you can refresh the page. And as soon as you are done with the quiz, you have 12 minutes to complete these quizzes. Now, regarding this quiz, I have done something interesting this time around. So there are no, this quiz are meant only for your self-evaluation. Okay. So earlier, when I used to, till last semester, when I used to keep the quiz, there used to be some part of the marks of the quiz were included in the term work. So what I have done from this time onward. So then what used to happen? Students used to like immediately used to copy the quiz from each other. All right. So that defeats the purpose. Okay. So from this semester onwards, what I have done is that there will be no marks for this quiz. There are marks for the quiz, but that are only for your self-evaluation. Is that clear? As far as the term work is concerned, these quiz are completely excluded from the term work marks. All right. This is just for your self-evaluation. So whatever lecture you have attended today, how much you have grasped. All right. So there is no point in stealing answers from your friends or doing such kind of things, because it will be detrimental to your uh, to yourself. Okay, so anyway, you still want to copy that, then you are just cheating yourself. You are not cheating me. All right, so 11 minutes to complete the quiz. As far as I am concerned, see, the notes have been already given to you. You can refer the notes and answer the quiz. Or if something is not there in the notes, I tend to give that things in the lecture. So all the things which I have asked in the quiz is based on the lecture which has just concluded. The online system has made students habitual to copying. So I am trying to minimize the effects of this online system. So once you are done, after 10 minutes, I will be posting the answers immediately. So we'll get a quick feedback on how much you have grasped today. And it will also give me a feedback that how much you have grasped today, or how much I have communicated to you, was that beneficial. In fact, the quiz are not at all compulsory. If somebody doesn't want to answer the quiz, then you don't have to answer the quiz also. It is completely up to you. If you feel that that is a waste of time, then that is also, there is no compulsion in answering this quiz. Practicals will be will not be conducted this week. So maybe it will take couple of weeks to for the practicals to start. I don't know why that is the case. But
For all the subjects. Sir, for all the subjects.
yes, this week no practicals.
So what are linear and non-linear models for explaining vibrations?
So I have not covered that part, I think. If there's something just I think I have not covered that part in the lecture. Linear, non-linear vibration. Okay, that part will be covered. I have not covered. Linear means basically you have a linear model. Okay, and once that cannot be expressed in form of a linear model, I mean, I think that question needs a better explanation. So what you can do is just ignore that question. Or just a minute, I will eliminate that question. It is in which quiz?
Sir, quiz 2.
Any other question which I've asked which is not been covered?
Yes. Sir, in quiz 2, most of the questions are like that.
Yes, sir. Yes, sir.
Just let me check. Let me check. But I think that content may be coming up in the next lecture. So, no, you can answer that those quiz in that quiz in the. First question you can ask. You can answer.
Yes, sir.
It is about a discrete.
Except that all other questions were, I think it's not covered in this lecture.
Okay. So okay, don't answer this one_2. Answer the other two. Yes. So all these things are covered in the next lecture. So you can answer this quiz in the after the end of the next lecture.
Okay, sir.
In fact, I will disable the response so that and I'll delete all the responses also. So it is all cleaned up now. So you can answer that question in the next lecture. Go ahead and rename it as lecture 2_1.
Sir, can we skip the second quiz?
Pardon?
Can we skip the second quiz, sir?
Yeah. Skip the second quiz. 1_2 you can skip. Even if you have submitted, I have cleaned up the the responses so that you can again answer those questions after you learn about that stuff. Just answer 1_1 and 1_3. Are all the diploma students included in the? Are they able to access the lectures? Are there any diploma students there in today's lecture? Hello.
Yes, sir.
Yes, sir.
So I think there were 7 students. So I have added those students also. They were not there in the original list.
Sir, done with the quiz.
Pardon?
So done with the quiz.
Yeah, there are some students who are still remaining. Can I publish the answers of the first quiz? All of you are done? 1_1.
Yes.
Everybody's done?
Yes, sir.
What about 1_2? Or
No, we have
1_3?
skipped that.
Some
1
of them
is
are
done.
still. Huh?
Yes, sir, it's done.
Okay, so I can see only because 1_1 I can see 50 responses and 1_3 I can see only 27 responses. So some students are still doing it. So just wait a couple of minutes more. I will publish the answers for both of them. So I will be sending the lecture notes of the next lecture on the prior day. I will be sending it to one of your class student. Do you have any other questions? Because the pace is going to pick up very quickly. Today's was a very what do you say, slow paced lecture. The subject is completely mathematical. Diploma students might find it difficult. So what I would suggest is that there are some very good courses on integral calculus on NPTEL. Okay, so no, just to enhance your mathematical skill, I would suggest that you do those courses, because in diploma the mathematics part is not that intense. These days it is like even more poor. So unless you are unless you pick up that mathematical aspect, as I go along, this is going to be excruciatingly mathematical. So it is better that you start working on that. If you want me to suggest the course, then just let me know. I will go through the various courses available, and I will let you know. All these things, all these mathematical things are covered in first year mathematics. So many of those things that you generally all the other students learn in mathematics are used in this subject. So this is subject is like a completely applications of this mathematical principle creating. So what you will be doing is you will be creating a mathematical model. In the labs, you will be either simulating those mathematical models, or you will be working on the actual readings from, and then you will be ratifying those whatever equations that you have developed. Okay, so I will publish the results now. All right, so I have posted the scores for both the Quizlets. You can go through the answers and just go through the notes. If you have any questions, you can ask me later. All right, that's all for today. Thank you.
Thank you, sir.
All right.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.